roughly speaking. Oh, we're going to need a couple good functions, like let's let f of x be x squared, and let's let g of x be x plus 1. Now, so far in Algebra 1, Algebra 2, and even a couple weeks ago, you were given a function. It was f of x equals yada yada. And you were told to evaluate it at f of 2 or f of 4 or f of some number. And you put the number in, you calculate it, and you got a number back. Numbers are not the only things that can be input for functions. You can have functions be the input values for functions, and that's what a composition is. So if I were to evaluate f of x, but instead of putting in x, I use g of x as my input, it would be the exact same thing as if I told you to find f of 2. You would put 2 in for x squared, and you would square it, and you would get 4. F of g of x means you take f and you put g of x in wherever you see an x. So f of fire truck would be fire truck squared. F of Amelia would be Amelia squared. F of g of x would be g of x squared. And we know that g of x is x plus 1. And that is a composition. Not too bad, right? We could go the other way. We could evaluate g of f of x. That means you take g and you use the function f of x as an input value. G of x is x plus 1. G of an old tire is an old tire plus 1. G of f of x is f of x plus 1. And we know that f of x is x squared. That's simple enough, right? It's still pretty mellow, right, Bartolomeo? Mellow. The notation for composition is a little empty circle. So what I have just done, let's put it up here. What I have done up here was I had taken x composed with g of x. That's not fog. It's f composed with, and it's not times. It's not multiplication. It's an open circle, not a closed dot. That means composed. Down here, I did g composed with f of x. And it's not Goff, it's g composed of f. And it's not multiplication, it's g composed of f. What that means is take g and evaluate it with f of x as your input value. I wish I could make that harder. And if I look hard enough. Oh wait. Not harder, but this is about as hard as I can make it. Amelia, we are going to let f of x be the cube root of x minus 1. You with me? And we're going to let g of x be x cubed plus 1. Cube roots and cubes, this is crazy. And Amelia is going to guide us through finding f composed with g. Amelia, what does it mean to take f composed with g of x? Amelia? Put g in front of x? Amelia, what's it mean?
That's the same thing as that,
Right.
right? But for every x, you put the g in for it.
Okay. Well, I think what Amelia is trying to say is that F composed with G means that you take the function f of x and you use g of x as your input. F of x is the cubed root of x minus 1, Amelia. So f of the fire truck would be the cubed root of fire truck minus 1. F of, oh my God, F of Amelia's huge stack of books would be the cube root of Amelia's stack of books minus 1. F of g of x would be the cubed root of g of x minus 1. And we know that g of x is x cubed plus 1. What a bad way to leave an answer. Let's clean it up. Plus 1 minus 1, we have the cubed root of x cubed, which is just x. How convenient. Amelia, let's take g composed with f, just for fun, okay? Amelia, what does it mean to take g composed of f of x?
For every x that you have, you put that.
Yeah. You take g and you put f of x in as its input. G of x is x cubed plus 1. G of whatever you put in is whatever you put in cubed plus 1. Even if it's Amelia's stack of books. G of f of x is f of x cubed plus 1. Well, we know that f of x is actually the cubed root of x minus 1. What a bad way to leave an answer. We should simplify that. Well, the cubed root, cubed, is just x minus 1. And minus 1 plus 1 is 0, so you're left with x. This was a very special example because most of them aren't going to work out like this. Most that you do, f composed with g and g composed with f are not going to end up to be the same thing. This happens because f and g are inverses. On that page, 169, 19 to 26.